Hello, today we are looking at 8-2B in your notes packet, slope and rate of change. Our learning goal for today is I can understand the slope of a line is the constant rate of change and use it to solve problems.
All right, Tina traveled 3,600 miles in 9 hours. How fast was the plane traveling? In order to answer that question, we need to find the airplane's rate or unit rate, which is should be review for you. I don't have a lot of space up here where I need to put my answer, so we are just going to put it down on the bottom here. You can fit yours wherever works best for you. So 3,600 miles in 9 hours. We need to find our unit rate, which is 1 hour. So we're going to divide by 9, and that gives me an answer of 400. Okay, so my rate is 400 miles per hour. Now we need to fill out our table. Okay, I know that 1 hour is 400 miles. That means 2 hours would be 800, 3 hours would be 1,200, and so on. We could keep going. I'm going to jump all the way to 9 because we were told that 9 hours was 3,600 miles. Now I'm going to plot these on my graph. You do have to label your graph with hours and miles and add in your counting numbers there also, because those are missing from your notes page. So when I plot those, you're going to have to be very careful with a little bit of estimating. So 1 400 would be approximately there. 2 800 will give us about here. 3 1,200 works perfectly right on a coordinate point. And then we're going to jump all the way to 3,600, which is at 9. And that works out perfectly as a coordinate point. Also, we can additionally add in 0, 0, because obviously if you're not going any time, you're not going any miles either. All right, the second part of that problem is talking about a car's rate. So this one we're talking about a car that is traveling 60 miles per hour. If you notice the same graph is pictured, we're going to graph the car's rate on the same graph. So the first thing, the car's rate we already know because it tells us 60 miles per hour. Okay, so if I go 1 hour, that's 60 miles. 2 hours would be 120. 3 hours would be 180. We could skip. We can do, let's skip to 9 hours. 9 hours would be 540. Okay. So now we plot those on our number line. 160, you're going to do a lot of estimating here. 2 is 120. Again, lots of estimating. Same thing with 3. Okay, very shallow graph here. And then even at 9, we're at 540. So we're just barely getting almost up to that 600 mark. And then again, if we didn't go anywhere, we would be at 0, 0. So here's our graph for our car. And that is very shallow. We already had our airplane on the same graph. All right, so what is the slope of the line you graphed? If you were to count it, you would figure out that your slope is actually your unit rate. So if you look at the problem for your airplane, the unit rate was 400, so your slope is 400, or you could also say 400 over 1. The car's unit rate was 60 miles per hour, so 60 is your slope, or you could also say 60 over 1. Also notice that the airplane's graph was so much steeper because the slope is a lot bigger of a number than the car's slope. And then we can't forget, on the next page, if you turn in your packet, you have an arrow to fill in. Slope equals the rate of change, which is also called unit rate. So lots of words that mean the same thing. All right, problem number 1, Noah's birthday party and the cost for the guests. What is the rate of change or slope? Remember, rate of change and slope mean the same thing. Slope is your rise over your run. So you need to find coordinate points. There's one here that works perfectly. This one works perfectly, and that one works perfectly. It doesn't matter which 2 points you pick. You just pick something and you find the rise, which is 3. And then you find the run, which is 2. So your slope or rate of change is 3 over 2. What does that represent? Well, that's where the words come in, your labels, on your slope. So rise is your y-axis, up and down, y to the sky. So you're going to look at your y-axis for the label. That's cost, so $3. And then for every, and then we need to look at your x-axis, which is 2 guess. And very important that your order matches your slope. So 3 comes first and then 2. And make sure your labels match your x or your y-axis as well as your x-axis. All right, student council and selling pop. Money collected, plot the data. So the first thing you need to do is plot your coordinates, 0, 0, 1, 3, 2, 6, and 3, 9. That should make a straight line. And then letter B, what is the rate of change or slope? So that's your rise over your run. Again, pick any 2 points, it doesn't matter. You rise up 3, and you run 1. So your slope is 3 over 1, which is the same thing as just 3. And it is positive. Your little dude is sitting down here, going up. So positive 3. What does that represent? Here's where the words and the labels come in. So y-axis is what you look for 3. So $3. And then your x-axis is your run, which is the number of sodas sold. So $3 for every 1 soda sold. Remember, order matters. 3 comes first. So 3 comes first. That is the end of your video. Thanks for watching.